Hey, welcome back, everybody. This is the last installment for lessons on implicit differentiation. The topic today is we want to differentiate the equation twice and find what we would call the second derivative, the derivative of the derivative. Okay, and that's what the symbol is right here. A synonym would be y double prime. All right, and so I have an equation, x squared plus y squared equals 25. And we're going to find its first derivative, y prime, and then we're going to differentiate a second time to find y double prime. Remember, the key, the very important notion here is that it's always implied that y is a function, f of x. So when I'm finding derivatives of all the terms, if I'm differentiating things like x squared, I'm just differentiating as usual, using whatever differentiation rule is needed. And if I'm differentiating something with y in it, it's always thought of as a function within a function, and so we use the chain rule. Okay, so I'm going to be putting my derivative symbol around every term. I'll go ahead and do that now. So like I said, if I'm differentiating something like x squared, we just use the normal differentiation rule, such as the power rule. If I'm finding the derivative of y squared, that's now thought of as the function f of x squared, and we use the chain rule. So it's almost like a regular derivative, but then we multiply by the derivative of the function y. So 2y, y prime. And then the derivative of 25 is 0. And so my first task is to solve for y prime. So I'm going to subtract 2x from both sides. So 2y times y prime equals negative 2x. And I'm going to solve for y prime by dividing by 2y. So y prime is negative 2x divided by positive 2y, but I can divide out 2 here and be left with the negative of x divided by y. Now I'm going to circle this, not because it's the final answer, but just because it's kind of our first kind of checkpoint here, that we have the first derivative. And now we start with this equation, and we find its derivative. So if y prime is negative x over y, we're now going to apply a derivative again. Okay, and if you think of, and that means we're going to apply it to both sides. So I'll actually write it on both sides. Again, if it involves y, we use the chain rule. And not only that this time, but the expression on the right is in the form of a quotient. So right away I'm thinking there, I'm going to need to know the quotient rule on this right side. Okay, so starting on the left, the derivative of the derivative is automatically the second derivative, y double prime. So that's the thing we're trying to find. On the right, we're going to be applying the quotient rule. So the high is the negative of x, the low is y. Keep in mind the chain rule anytime we see y, though. So if I'm going to make my template for low d high minus high d low, all over the square of what's below, I've got low d high, which is going to be y times the derivative of negative 1x, which will be negative 1, minus high d low, so negative x, times the derivative of y, which is y prime. It's all over y squared. Okay, let me take a minute and rewrite that again, but without as many parentheses. So negative 1y, which is negative y. I've got minus minus here, so that's going to be plus x times y prime. And then I've got y squared. Actually, I don't have too many squares there, don't I? So it'll just be y squared. Now, all the calculus is over, but we're not going to leave the answer for y double prime with x, y, and y prime in it. So no, we already know an expression for y prime. Okay, so what we're going to do next is I'm just going to make a note of it here. We're going to substitute negative x over y for y prime. So that way everything in my expression for the second derivative will only be x and y, not y prime in it. And then there'll be a little bit of simplification to do. Okay, so I've got double prime equals negative y plus, now I'm going to write both of these as fractions. Okay, so x over 1 times negative x over y. That's all over y squared. So my next simplification is to multiply these two fractions together in the upper right corner. It'll be negative y. I've got a negative sign now, so I'm going to make that minus, and I've got x times x squared over y times 1. It's all over y squared. So technically, it's good that I've got everything in terms of y and x now. There's no y prime. However, I'd really not like to have a little fraction inside the big one here. So my last little bit of simplifying is to multiply above and below the main fraction bar by the denominator of the little fraction y to kill that little fraction. Okay, so now across the top, all times y. I'll start on the left over here. Y times the negative of y is negative y squared. Y times the x squared over y would kill the y denominator, so it's going to leave you with minus x squared. And then on the bottom, it's y squared times y, which is y cubed. Okay, technically now this is good. Everything is involving y and x. There's no little fractions inside of the big fraction. That can be your final answer. Now, sometimes clever students will notice other things you can simplify here. Please don't feel like you need to go digging and looking for this, but notice something really clever in this answer. If you factored out the minus sign in the numerator, it would leave you with the expression y squared plus x squared all times the negative 1. And look at that. That's the exact expression that's in our original equation. It's in the wrong order, but when you're adding, that doesn't matter. So y squared plus x squared is the same as x squared plus y squared. So I could actually replace that whole quantity with 25. So an alternate final answer could be to put negative 25 over y cubed. This is only an alternate answer. It is not, the official best answer in any way. Both things that I circled are perfectly fine. Okay, sometimes when you're done in the second derivative, you can often find a way to involve the original equation again, but please do not feel like you have to do that. This is perfectly fine. When we had negative y squared minus x squared over y cubed, that can definitely be your final answer. Well, I hope this helps, guys. There's a few in your problem set where you find the second derivative. Make sure you're looking for things like the product rule and quotient rule in there too. As we saw, this one required the quotient rule. And hope this helps if you need it, and talk to you soon.